Hello, guys. Welcome to the Senior High School Mathematics Forum. My name is Steven, and I'm bringing to you differentiation of implicit functions. So now, guys, all that while we were doing differentiation of explicit functions. Now let's look at that of implicit functions. But let's first differentiate between those two before we move on. Um, Implicit functions, let's talk about the explicit that we're doing already. Explicit functions are functions that have one variable expressed as a function of another, like one is the subject and the other one is the relation. That is, let's say p is equals to t cube plus t square plus 1, q is equals to v square plus v, and then y is equals to x minus 1. All these are explicit functions because only one variable in the relation being expressed as a function of this variable. Have you seen that? Here to same, here to same. But let's talk about the implicit one. The implicit one, when it comes to that one, we have a lot of variables in the equation. Why do I say this? I say this because let's say this x plus y squared is equals to 0 is an implicit function. Look at this. But x squared plus y plus y squared is equals to 0 is an implicit function as well. But the above is an implicit function and not. Why do I say this? Because it can be expressed in this way. X is equals to minus y squared minus y. But you can still use explicit functions to differentiate this. Implicit function form to differentiate this. No problem. But it is not an implicit function because it can be expressed in this way. Let's look at the second one. Can it be expressed in this way where x can be the subject? No. So that means that one is an implicit function, and we can have as many as variables we can think of. Let's talk about a line in space. You don't know that, but let me just write this equation down. A line in space can have an equation x plus y plus z with one coefficients being 1 1 is equals to plus, let's say, 2 is equals to 0. This can be an equation of a plane. An equation of a plane. Have you seen that? We can also have an equation of a sphere. This can also be an equation of a sphere. So guys, this is all about implicit functions. So these two that you are seeing, including this one, are implicit functions. So we know how to differentiate this one with respect to the relational variable. That is, if they say differentiate q with respect to v, you will know how to differentiate it with, from our previous knowledge, which will just be 2v plus 1. With respect to x, which will just be 1. With respect to t, which will just be 3t squared plus 2t. You know all this. That is, we've differentiated these three explicit functions like that. Now, let's look at how to differentiate the other three implicit functions. How do we differentiate them? Though there are 3 variables, 4 variables, or as many variables as you can think of there. But what do they always say? Differentiate with respect to a particular variable. So when they say that, what will you do? Firstly, look at the let's look at the last implicit function rather. So looking at that one, if they say we should differentiate with respect to x, guys, what will we do? X is here, so it will be easier. Differentiating with respect to x, we will get 2x. What of this one? It is not in the form of x. That is, the variable is not x, it is rather y. So how do we differentiate this one? Implicitly. So we do so by differentiating this particular function, this particular variable with respect to itself first. That is, we will have 2y, then multiplying that by just taking one of it and differentiating it with respect to x. So this will be how it will be. This is how it will be. Then this one, same, will have same way as this one was done, is equals to 0. Then guys, you have finished differentiating like that, but you need to show them that you are a mathematician by identifying that 2 can we can get rid of 2 out here. Now leaving the final equation as this. That is our differential now. Let's move on. Let's say when you have something like this, 7 plus y power 7 plus 3 is equals to 0. They say differentiate this one to know that it is an implicit function. And note, some implicit functions can be expressed in the form of radicals. So let's move on. So when you have something like this, what do? We can differentiate it implicitly. So in differentiating this, they will either give you the variable. Differentiate with respect to y. What will you do? You have this one differentiated with respect to x. That is 7x power 6. Then multiplying by differentiating only one with respect to x and with respect to y. The y, have you seen that? We are differentiating the whole of this with respect to y. So this one will now be plus 7y power 6 because we are already differentiating this one with respect to y. And then you can also follow that same procedure that I told you. When you are differentiating implicit functions, you differentiate it first with respect to itself. Now multiplying by differentiating one of that letters with respect to the given letter. So you can apply same here. When in applying same here, let's see, we are differentiating this with respect to y. So we'll have y itself, that's the letter. We'll have 7y power 6. Then multiplying by differentiating one of this with respect to y. So when we are differentiating this with respect to y, what will we get? We'll get 1. 1 multiplying by this is the same. So guys, have you seen how it is done now? Then we'll have it equal to 0. Then same way, when you have x power 6 plus y power 6 plus z power 6 is equals to 0. And we are differentiating all this with respect to x. What do? We differentiate x with respect to x. We are differentiating the implicit function with respect to x. But first, we will differentiate this with respect to x. And then we'll have 6 power x power 6 multiplying by x power 5. Then multiplying by, then differentiating this with respect to x again. That is the variable. Meaning first, you differentiate it with respect to itself. And then differentiate it with respect to the variable given for you to differentiate with respect to. So differentiating one of the variables with respect to, like the variable itself, x itself with respect to x, we'll get 1. So 1 times this is that, still that one. Then differentiating this with respect to y will give us what? 6y power 5. But they didn't say we should differentiate with respect to y. What will we do? We now differentiate one of these variables, one of the variables, that's the variable with respect to y. with respect to x rather. So we now have the y, the x. Have you seen that, guys? Same applies to this one. Same applies to this. Then we have it equals 0. So as a mathematician, you realize that this will go out with this and go out with that, leaving the final expression as below. So that is it, guys. So this is just differentiation. That is implicit differentiation. That is differentiation of implicit functions. That is it. It is as that. So guys, when you have two variables, let's say x squared, x power n, let's say x power n plus y power n, then plus any other this thing in that value in terms of x and y is equals to 0. What do we do? Using a shortcut, you can differentiate this. In using that shortcut, we will have guys, when you are differentiating the whole function with respect to x, then we'll have it as dy dx is equal to, then you differentiate x first all over the differential of y. Guys, have you seen that? But when you are differentiating with respect to y, you have dx over dy is equal to, so take notice of that, f prime of y all over f prime of x. So guys, let me solve an example here so that you all see how it is. Now, this particular differential, we could have rearranged it. In rearranging it, what would we have gotten? This is it. We would have gotten dy dx. So negative of that, guys, negative of that. So we would have gotten dy dx is equal to this one. When you take it across, it becomes negative 7y power 6. Then divided by 7x power 6. Then what do we get? We get minus y power 6 all over x power 6. As simply as that. Guys, so when we are to differentiate this using the formula, but we know that they are differentiating with respect to y. So what do? We use this one with respect to y. We use this one. So in using that one, it tells us that we'll differentiate y first. We'll just say our dx. Sorry, it was the x, dx dy. So we'll just say our dx dy straightforward using the formula is equal to minus of what we are going to differentiate, and then get. So minus of the said f prime of y here. Simply, it is, you are differentiating every y you see, whether it is attached to what, every term containing y, or every y, and then taking the others as constants. So when you differentiate this, you get 0, taking it as a constant. This you will get 7y power 6. That is with respect to y. And this as 0. So now, when you come, you have 7y power 6. Then the down one, you do same to the x. Remember, I told you that it is only limited to two variables. So let's move on. We will have it over the differential of x power 7. And then any other term containing x. In this our case, we've realized that there's no term containing x apart from x power 7. So those terms, all the differential of them become 0 because they are assumed to be constants. And this one, when we differentiate it, we will have 7x power 6. This 7 will quickly go away with this. They won't forgive each other. Then our final answer will be minus y power 6 all over x power 6. That is the x over the y. Then you can find the y over the x. And guys, you don't need to go through that same procedure. What you need to do is that you take the reciprocal of the x over the y and you will get the y over the x. Simply as that. All these tricks, we will look at them when we are doing application of differentiation. So let's say you've differentiated something and you've had the y over the x to be equals to 2, and someone asks you that, oh, you just find the x over the y. Sorry, I wanted to say the x over the y, and I said my mouth slipped and I said the y over the x. So what will you do? Guys, you don't need to go through the whole procedure. The answer you've gotten, you don't need to worry. Saying that time will beat your other things. Nah, what you need to do is to take the reciprocal of the y over the x and you will get the x over the y. That is half. Have you seen that? That is if you are differentiated a particular function and gotten this. So it is as simply as that. It is as simply as that. So please guys, to get more videos, to get in touch, in fact, to get more knowledge from me, subscribe and turn on the notification bell. Also, share, and also comment on what you beg. Please, what you dislike, don't go and press on the dislike button. I beg, your dislikes all should be your comments. Your dislikes all should be your comments, and I will address them and bring the best videos of mine to you. Thank you. Thank you. I hope you join me for the next video on differentiation of trig functions. Thank you.